Hello and welcome to Math AASL Chapter 7. So this video is actually going to be 7.1 and 7.2 combined because they are really short. As always, I have no credentials. I'm just a student. I feel like I say that for legal reasons, even though there are no legal reasons. That didn't make any sense, but you know what I mean. Okay, so let's get into it. So 7.1 is about scatter diagrams, specifically. Actually, this chapter should just be called correlation. I don't know why it's called scatter diagrams, but it is. So a correlation is a relationship between two variables. So if you drew a scatter diagram, you would say x increases or decreases when y increases or decreases. Now, these diagrams and correlation is used to describe bivariate data analyses. And these are analyses between the relationship of two data sets. So this could be, for instance, height and weight, or smoking and lung cancer. These are very basic ones I'm giving now. Or they could be really weird things like Internet Explorer, the use of Internet Explorer, and murder rates, which according to BuzzFeed are correlated, which is weird. Yeah, so you guys better start using Chrome if you already haven't. I don't think anyone really uses Internet Explorer anyway. So what you have to know about correlations is linear versus nonlinear. So when you're explaining how the scatter diagram looks like, it can either look linear, as in like a line, or not. So this example I'm drawing right now is linear, meanwhile, the next one is not. The next thing you use to describe the correlation is negative or positive. So a positive correlation would be when x increases, y increases. So that would look like a line going from 0 to the top right. Meanwhile, a negative correlation would be y decreases as x increases. The next factor is whether it's a strong correlation, moderate correlation, or weak correlation. So in this case, it doesn't matter if it's positive or negative. You can have a positive weak correlation or a negative weak correlation. That doesn't really play a part in that. This middle one is a strong correlation, a strong negative correlation specifically, and it's linear. This one is a moderate positive correlation. And the other one is a positive weak correlation. Actually, it's very weak, bordering on no correlation. And you do this just by sight, but in chapter 7.2, that will come soon, you will find out how to determine whether it's weak, moderate, or strong using actual maths and not just vision. Now, little or no correlation is just when it's scattered. All the data is scattered, there is no line, no distinction, nothing. Which means that there isn't really a relationship between the two factors. There just isn't one. So the last thing you have to remember about correlation is that correlation does not equal causation. I'm sure you've heard that a million times. And if we bring it back to the example from the beginning about using Internet Explorer and murder rates, yes, their graphs, their points, data points may correlate, they look similar, but no, it is not correct or caused by each other. Just because you use Internet Explorer, it will not cause someone else to murder anyone else. Here is a quick run-through of all of the different types of correlation. The P stands for positive, the N stands for negative, the W stands for weak, the M stands for moderate, and the S stands for strong, and the no stands for no correlation. And as that continues, that is it for this chapter. Yes, that was literally all of it. There is nothing more, and we will be starting with chapter 2 in just a couple seconds. I mean 7.2, just to clarify. So, 7.2. Chapter 7.2 is measuring correlation. Yet again, this is a chapter with only one thing, literally just one thing you have to learn. So this will hopefully go very quickly. This is how you find out what the correlation is by using actual maths, not just looking at the graph. So you could get scatter graphs where it's very hard to tell whether it's weak or moderate, or weak and no correlation whatsoever. And because of this, you can use the Pearson product moment correlation coefficient, which is denoted by the letter R. And essentially what you're looking for is this R value. So the R value can be anywhere from 1 to -1. Even though I'm sure we all have different calculators, I will do a very, very quick rundown of how you can find R using the specific calculator I have. If you have a different calculator, research this. It's very important. You won't ever be asked to figure it out without a calculator. In fact, I don't even know how to figure it out without a calculator. So I have the Texas Instrument TI-84 Plus. That is the calculator model. So what you do is you press the button Stat, and then you go into Edit and type in your values. And then you go back into Stat and then use your little arrow key, like movie aroundy thingy, to go to Calculate. And in there, on the fourth number, there's something called LINREG, and you press that, and when you press that and press enter, then they give you R. Wow, okay, great. Hopefully that helped like one person who has the same calculator as me, but that's okay. So, what is important about this is that you have to know that depending on what number you get, it would either correlate to weak or moderate or strong. So if your number is between 0 and 0.25, you have a very weak correlation. If you get your R value to be from 0.25 to 0.5, it is weak. From 0.5 to 0.75, it is moderate. From 0.75 to 1, it is very strong. So this is how you see what the correlation is using math. But remember that this can also be negative. So if it's closer to -1, it's also a stronger correlation, because if you have a negative correlation, it will be negative. If you have a positive correlation, it will be positive. Now it is time for the quiz. This quiz will both quiz you on 7.1 and 7.2. So the questions are: describe the correlation, whether it is linear or nonlinear, whether it is weak, strong, or moderate, or whether it is positive or negative. And the second question is, what is the R value of this data? Now feel free to pause and come back when you have your answer. Now I'm going to answer the question. So, describe the correlation. It is linear, it is strong, and it is positive. You can see this because it's in a line. It's, as I said, it's in a line, so it's linear and it's strong, and it's, as the x increases, the y increases, so it is positive. The R value is 0.99, which means it is a strong correlation. So we just proved that it was a strong correlation. So that was it for chapter 7.2 and 7.1. Feel free to subscribe, like, and comment. Follow me at Johanna Frennert, and goodbye!